Okay, so this week we will have some discussions on some of the IoT and internet and wireless communication basics. And next week we'll have some Python program discussions. Okay, so just some basics. Okay, some basics, and that we're going to use during the workshop. And then after that, we'll discuss some commonly used sensors and sensor interfaces. So we'll introduce different kind of the boards that we can use. And then followed by 4 projects. So the first one is we will implement a project that collect data from a BME 280 sensor that is connected to a Raspberry Pi through the R2C interface. Then we're going to implement a Flask web server so that allow you to access the data via a web page. Okay. We will also discuss how to implement, how to use the IoT platform that called the initial state for some web applications. So that's the first project. And then second one, we will discuss how we're going to utilize that MQTT protocol, implement and utilize that to connect node MCU modules with sensors to a Raspberry Pi via Wi-Fi connections. So that's a second project. Then the third project is we were going to add the access directly, Google Firebase real-time database. So we're going to send the data to a database in the cloud for our applications. Okay, that's the third project. Then last one, we will have some integrations of the data visualization implementation. So we will utilize Plotly Dash to create an interactive data visualization interface. So you can better check the collected data. Okay. So that's the overall the project, the 4 project are going to implement it. Here's some of the comments, the components that we're going to need it for our project. Okay, so Raspberry Pi, of course, you're going to need it, and then a couple of the Node MCU board, and a couple of sensor boards. So BME 280 is easy to work, so you can purchase a few of them. Shopping list. I think over here is a link. So I put in a link. You can click in the slides. I believe in the PDF file you should be able to access them. But you can search online with that. There's plenty of the vendors still then. So you may probably find a better deal. Okay. Yeah. So you also need some jumper wires and a breadboard, to make the connections. Okay, so those are components needed. And for today, okay, that's the outlines for today's presentation. Okay, IoT. Today we'll just talk about some fundamentals about wireless communications. We'll talk about the OSI 7-layer model and TCP/IP a little bit. Then we talk about IP address, hardware addresses, or the MAC addresses, the difference, how they are used, and how to find them. And then we will talk a little bit about the Wi-Fi network or the wireless local area network, since most of our project is built over the Wi-Fi. Okay, so we're going to also have some overview about that. The last portion, the second part of the presentation, we'll talk about the publish-subscribe protocol, MQTT. Okay, so we'll learn how to set up a MQTT broker, use the Mosquito package, and then test it out. Okay, so that's today's plan. Okay. When we talk about Internet of Things or IoT, we needed to know how Internet works. So the Internet links millions of the billions of the devices via array of the network equipment, routing devices, and different communication methods. So let's have a look at the history briefly, okay, just a little bit. Internet is originated from ARPANET back in the 1970s. Quite amazing, right? And it was renamed as Internet in 1983. And at that time, the military use of the network or the Internet is separated from the Internet. Okay. In 1995, only less 1% of the world population has an Internet access. But by 2022, over 5 billion, there's already have over 5 billion users. We can see over here, over the past 20 years, that number of the users of the internet increase exponentially. Okay, it's so faster. And then pretty much we will now have over roughly 70% of the population has access to the internet. Okay. So let's see, because the internet has connected billions of different devices together, it is very complex, right? So how to describe such a complex system? Okay. People then developed a so-called 7-layer model, this named as the Open System Interconnect Reference Model, or OSI reference model. Okay, it's established back in the 1984, which provides a conceptual and a functional blueprint of the interconnect networks. Okay, here's showing that 7 layers. Okay, in this figure, it shows overall 7 layers. From the bottom to the top, they are physical layers, data link layer, network layer, transport layer, session layer, presentation layer, and application layers. Okay, total 7 layers. When we discuss internet and different components of the internet, this OSI 7-layer reference model is commonly used. However, the actual implementation of the internet does not follow this OSI 7-layer exactly. Share screen. Share screen. I just share the screen. Can you guys see the screen? Oh, okay. Okay. Thank you. Okay. I'm just wondering, I saw I shared the screen. I'm afraid you guys cannot see me. Okay, so the actual implementation is actually using the TCP/IP. You will see is actually using that TCP/IP suite. Okay, TCP/IP suite. So what is a TCP/IP suite? Okay, TCP/IP protocol suite uses simplified layers than the 7 layers. And that protocol suite is sent to two most important protocols, TCP, which stands for the Transport Control Protocol, and an IP, Internet Protocol. Okay. Initially, those are developed by 2 researchers from UCLA for the ARPANET. And then now there's many different kinds of thousands of the protocols, including in this TCP/IP protocol suite. There's one organization called the Internet Engineering Task Force, who oversees the development and the maintenance of the internet standard. Okay, internet standard. So here is the comparison of the OSI 7-layer reference model and the TCP/IP suite. So we see over here the TCP/IP suite is follows. Okay, over here is the internet layer, the most important, or the network layer. The most important protocol we use is the IP protocol. Okay, the IP internet protocol, the IPs. And the TCP/IP and the UDP, those two most important protocols working on the transport layer. Okay, then they don't separate application presentation and the separate layer anymore. Or the after that is the application layers. They have all different kinds of protocols developed for various applications. Okay, so the good thing. Shopping list. Okay, well, you provide a shopping list. Okay, so in that presentation, in the third slides of this presentation, I provide a list of the components. You can actually, I provide a link that you can purchase those components. Okay, and then the presentation slides is I just shared the link with you guys. I can share it again. So my computer is a little bit slow now because of the shared screen. Okay, probably after my presentation, I can share the link again. Okay. So here's the showing, one of this figure is showing how the TCP/IP, again, the topic of this whole thing is rather complicated. Okay, we really definitely cannot cover within the 15 minutes, but I want to just give you the overview of it. Okay, so here's the TCP/IP architecture. What we can see, the protocol suite is implemented in a different host, like host A, host B, or you see in your computers, or that applications through the TCP transport layer and IP. We notice that over here, IP is a global network address. So it has to be unique. So like a million address for every person, right? In order to deliver a message from the host A to the host B, you have to have an IP address, a unique IP address in your host A and the host B, so they can be delivered. Some network devices in between, like routers and switches, those only needed to care about the lower three layers. Okay, they use the IP address information to determine the routing path, so they know where to route this IP package to. Okay, so this is a overall TCP/IP architecture. Now, let's have a quick question. So now, on which OSI layer does the Internet Protocol IP works? You could just through this link to answer the questions. Let's see. Are you be able to? Let's see. Can you access the link? I didn't see any answer come in, so was wondering what happened. I sent this to the over here. Just using a link, I send it to the chat window. Yeah, to the chat window. Yes, see, yes. Okay, network layer, indeed, network layer. Okay, I don't know what happened, but you guys are all correct. Great. Okay, we'll have a look at that IP protocol briefly. Okay, so what's an IP protocol? The key to the success of the internet is that internet protocol. Okay, it is a connectionless best ever protocol. That means each IP datagram, each IP package is treated independently and may follow different paths. So it is pretty like a loose connection list kind of protocol. It allow the so it provide a very good scalability. It allows the internet to even expand to a billions of the users, billions of the nodes. It can still run robustly. Okay, so within the IP protocol, the one of the really important thing is come with the IP address, which we use all the time. So IP address is the global network address that's used to communicate among different hosts, okay, different devices. So it's has to be a global unit, and 32 bits. IP version 4 has totally 34 bits of address. Typically are written as 4 decimal numbers that separated by dots. So for example, we're showing over here the 134.161.7.207. Okay, so each number, okay, they are actually represented by a bit. So with the a binary bit, so 1, 0, or whatever the binary bit, with the a bit, each number has to be between 0 to 255. Okay, so there's not going to see any number greater than 255 for IP version 4 addresses. Okay, that's the IP address. Often we will also talk about another address. It's called the physical address or MAC address. Each network interface has a hard-coded MAC address, which stands for the median access control address, median access control or MAC address. We also call them hardware address sometimes. Because this is also a globally unique address that tied to that hardware, tied to the hardware or tied to the network interface card. And the MAC layer or the MAC address is working on, we can consider is address in the data link layer or the second layer, okay, and the second layer. The MAC address has 6 bytes or 48 bits, and typically are written as hexadecimal numbers separated by semicolons. Okay, so by the columns over here. Sometimes also by the dash. This is the examples. The first 3 bytes or first 3 bytes or the 3 hexadecimal numbers I indicated it is from which vendor. So for example, in this example, we're showing this is from the Intel. Okay. So what's the difference between the MAC address and IP address? Those are 2 addresses we really commonly used. MAC address is the identifier of a network interface. So to compare that is, you can consider as a SSN of a person. It's tied to the network interface card or tied to your person, okay? It has to be a unique. And they only used for local communications when those 2 interface card, 2 interfaces are within the same subnet. They are next to each other, okay? Then you can use that SSN to identify it, or you see, okay, you steal the number. to identify it. They has to be in the same room, okay? So you can use that to identify it. That's the MAC address. Now the IP address is also called as a logic address. You can think about this is for the a mailing address of the person. So if I want to talk a person which is not in the same room, I need to send to that person a mail, then I need to then know his mailing address, right? So this is the purpose of the IP address. It just serves as a global network network address for the global communications, okay, for the internet. The IP address then needs to contain the information where the hoster is located, because the IP address is used for routing, okay, to determine where I can send the mail to, right? So that's the difference between your IP address and then MAC addresses, okay? And here's showing some of the examples, how you can identify it. That's some of the hands-on access. If you are in your computer, you can also open up one of the computer and just under the Windows search window, you can type in the PowerShell and then open this command window, the PowerShell command window, and type in the command ipconfigure the /all, and they will going to display some of that information about of your IP configuration or the network interface card. Okay, here's showing just one examples we see over here. Okay, that is the information we can notice over here. This is actually a wide network. They connected through the Ethernet, and we have a physical address. Okay, this is a physical address, and this one is showing that's IP address. So 134.161.141.50 is the IP address of this computer, and that is belongs to IP version 4 addresses. But we can also notice that over here, I have a DHCP server and DM server. And then the IP address is list obtained and then going to expire after some days, right? So that indicated that my IP address is actually assigned using is assigned IP addresses via so-called DHCP. The DHCP stands for Dynamic Host Configuration Protocol. So it's another protocol that is used to automatically provided IP address to a host, to a device, and also related configuration configuration informations when the device is connected to the network. Okay, they have to request an IP address. Okay, IP address. So this is some of the informations. So we see over here, we also have that gateway, default gateway over here. That the default gateway is the router interface that's connect to the same subnet, right? So like if you are at home, typically is going to be that IP address of your, for example, if you at home have a wireless router, okay, that interface or the access point of a wireless router's IP address is going to be your default gateway, because all your data to connection, all the datagram sent to the internet has to go through the router, has to go through the default gateway. Okay. In this case, as we're showing, the DHCP server and DM server is different from the default gateway. Sometimes they may also be hosted in the default gateway, okay, which is common if you're in whole network. So DHCP, here's just we talk about what's the DHCP protocol used for. But we haven't talked about what DMS server. Okay, DM service. Okay, we use the internet all the time, and then DNS or the domain name service, we use them all the time. But you're probably not aware of they are working for you. Okay, the DMS services allow hosts to translate a domain name or that URL to an IP address. As we know, in the internet, all the communication, okay, the mailing address of all those things are using what? IP addresses. So we have to know, in order to communicate with another host remotely, we have to know its IP address. However, it's difficult for us to remember the IP address, right? Those numbers. So how are you going to remember the 134.161 or whatever numbers? It's difficult. And that's why people introduced this DMS service, okay, the domain name service. So it can translate it that's a uniform resource locator to an IP address. So for example, if you connect it to www.umai.edu, it's much easier for us to remember www.umai.edu instead of numbers, right? Instead of numbers. So that DMS basically converting these IP addresses, obtain the IP address for these hosts. Okay, those are some of the private IP address that we use. You probably noticed many times when you set up at the whole network, they always use the 192.168 point something, right? What is that? Because those are private IP addresses. This is a range of the non-internet facing IP address. This only used for internal network. And it's typically used work with network address translations or NAT. Okay, here's one example showing the NAT. Inside, we use the private IP addresses. Okay, those private IP address. So you are never going to see in the internet observe any private IP address because they are private IP address, could not be reached by external IP address. So the router, all the package, all the messages leaving this router is actually going to use of the single that source net IP address. So all the we'll see that IP address given by the ISP to this router, okay, to this router. So the network address translation, the reason we introduced them is because we have a really limited, IP addresses. With 32-bit of the IP version 4 address, we only have around 4.3 billion unique IP addresses, which is certainly not sufficient, okay, to assign each IP address to all the devices connected. Remember, by last year, we already have over 15 billion IoT devices, right? So for 4.3 billion is not enough. And then use that private address combined with the network address translation, we can adjust this issue temporarily, okay? But it's come with some issues. So another thing which we use then is a solution is people introduce the IP version 4 address, okay? IP version 4 address. So instead of using 32-bit, we're going to use 128 bits, okay? That totally the number of that unique address and unique addresses will be giving this number, 340 unison. One unison equals to 1 trillion. So in the foreseeable future, we'll see there's more than sufficient of the IP address available if we all converting to the IPv version 4. Right now, still most of 90, I see one of the data said that 95% of traffic in the internet still IP version 4 internet, although roughly 1/3 of the devices now support an IP version 6 already. Okay, so different from the IP version 4 address, the IP version 6 addresses is written as A groups of 4 hexadecimal digits, as showing over here, separated by columns. Okay, so like example over here is pretty long, right? So with the meaning of the zeros, then we could drop it. So like over here, this is also a valid IP version 6 address. If you have multiple zeros, you just use double columns. Okay, use the double columns. Let's look at one example. That's how we can check the IP addresses of the IETF.org web server using the NS lookup. Okay, now this is a utilized DM service, and then we will return the IP address of the IETF. You can see over here that's returned some IP version 6 address, and then next to those are the IP version 4 addresses. Okay, nowadays IP version 4 is still dominant the use the traffic on the internet. Okay, so that's about really brief discussion of the TCP/IP suite and the IP protocol. Okay, so we are use the Wi-Fi, right? There's many different wireless communication standards existing. I mean, with limited time, we don't have the time to discuss all of them. I listed some of those information over here. But today, what we will just have a look at is about the wireless LAN or the Wi-Fi. So typically, the range for a wireless LAN is about up to 340 feet or 150 meters. The data rate with the latest the standard, it can support up to the 6.9 Gbps theoretically. Okay, I don't think those are available in the market yet. So when we talk about wireless LAN, we typically will just talk about the Wi-Fi. So what is Wi-Fi? Wi-Fi is actually come from the Wi-Fi Alliance. That is an industrial consortium that promotes the Wi-Fi or promotes the wireless LAN network based on the IEEE 802.11 standard. IEEE 802.11 standard, the original one was published in the 1999, and then over years they keep adding amendments. Okay, so to improve its performance, the data rate, working on different frequency. Okay, the latest revision, the big revision. Okay, big revision is that 2021. But from that time to now, they also added different more amendment. So like after several years, then they will combine this amendment to a new revision. Okay, new big revisions. Okay, the 802.11 standard is pretty much only working on what the address issue on the lower two layers, the data link and the physical layers. So the good thing about of the internet, how the internet works, is that the IP address or transport these two layers IP address or the network layers of the protocol remains the same. But then I allow different kinds of medias, different kind of devices, support different standards. Okay. And for the wireless LAN, the upper layers works the same. We still use the TCP/IP. Okay, we still use the TCP/IP. But for the Wi-Fi, okay, that connections mostly address the lower two layers. Here's some of that basic thing about operating frequencies. There's two major frequency bands we use. One is called the ISM band, which is working on the 2.4 gigahertz. Okay. Here's the different standards amendment supported. And another one is the so-called unlicensed National Information Infrastructure band on the 5 gigahertz. So we can see the total bandwidth on the 5 gigahertz is much wider. So 200 plus 355, that's over 500 megahertz. While in the 2.4 gigahertz is only a 3.5 megahertz. So the data rate in supported typically in the 2.4 gigahertz is actually lower. Since in order to support a higher data rate, you need a wider bandwidth. Okay, each channel needed to be a wider bandwidth. Okay, so over here we can see if we support those, it will have a relatively slow data rate. However, because working on low frequency, they can cover a longer distance. For the 5 gigahertz, they can support a faster data rate. However, they will cover relatively shorter, okay, distance. Okay, here is the some of the components we typically use. You need a device that with the network interface card will support that Wi-Fi functions. And also the network need a access point. Typically, a wireless router will support that. Okay, at home, you're going to have that. There's 3 major different operation modes supported by the Wi-Fi or the wireless LAN. The mostly commonly used one is the infrastructure mode, okay? In this case, we're going to have access point and the wireless devices. The Wi-Fi devices, the end devices are connected to the access point. They can also divide into basic service sets, which only have one access point and extended service set. They may have a multiple of that access point with the same service set identifier, which basically is the network name. Okay. For example, the UMI. In this case, I'm showing that the wireless LAN network status on my Raspberry Pi. So we can see it is actually connected to the EDU-ROM, which is in the infrastructure mode, okay? Which is in the infrastructure mode. And is working on what you can see over here, 2.4 gigahertz and data rate with a data rate of 72 megabps. Okay, megabps. So this is one of that operation mode. They could also working on the peer-to-peer mode or the ad hoc mode. Another one is the mesh network. Okay, they also supported the wireless mesh routers. In that cases, only one of the router need to have the connection to the wired network, and other routers can communicate it wirelessly. Okay, and then create a mesh network. So this is some of the wireless LAN operation mode. Okay, so we don't have time, but okay. Okay, so the last part, we'll just talk about the IoT communication models. Typically, they have either request and response model, okay, or publish and subscribe model, okay. Here, we will talk about that publish in a subscribed model. Okay, this is commonly used in a cloud-based or distributed system. Okay, so it's suitable for the IoT. Okay, so how the publish and the subscribe model work? Let's have a look. This one is a broker. Okay, so you're going to always need to set up a broker, which is in charge of the message exchange. The publisher is going to send a message to the to any subscribers through the broker. They are not going to send it to the contact the subscriber directly. Okay, directly. So for example, over here, I have 3 publishers going to publish messages with the topic 1, and I have 4 subscribers subscribed to the topic 1. So if my publisher 2 is going to send a message on the topic 1, that message going to send it to those 4 subscribers. Okay, so this is the typical publish and subscribe model. Okay, we'll discuss one of these protocol implement this model. Okay, and this protocol is named as MQTT, the protocol. Okay, so the message querying telemetric transporter. Okay, that's MQTT protocol. Originally created by IBM, but now it's an open protocol. The good thing about MQTT and why they are widely used for the IoT, it is really lightweighted. So the MQTT kinds only requires minimal resources on the devices, which is very good for the IoT devices. For the IoT applications. Okay, so there's many different softwares that support these MQTT protocols. We are going to use one of them, which is called the Mosquito. Okay, so Mosquito is one of the good thing about Mosquito is open source, totally free. You can download it online. It does support the iOS and the Windows and also the Linux. So we're going to set up a broker, Mosquito broker, in that Raspberry Pi. Okay, it support different versions. You need to install this package once you open the SH terminal and you're going to run this. Sudo stands for, okay, sudo stands for the super user do. So it will just give you the privilege of, you log into the terminal to the Raspberry Pi, use your own account, use the normal user account. But when you install software, you need the root user. So here you don't need to use root, but you use sudo. Okay, sudo command to do this. So we're going to install this Mosquito and also some of the Mosquito kinds, which we can use to test if the Mosquito block installed properly and works fine. Okay, so we're going to look at some of these examples. I'm going to show you briefly over here. Okay, let me see here. Where's my window? I can just show the demo. Why it doesn't show up? Okay, hold on. Let me doing this, and then where's my window? Try to find my window. Hmm? Okay, so this, can you guys see my screen over here? Okay, so I think it should work. Okay, so this one is I connected through the SSH to one of my Raspberry Pi. Okay, and then a couple of things we want to check. I already installed. It will take a few minutes to install the Mosquito, but I already installed. Okay, so what we are going to see is we want to check if this one is. We'll just check a few things. Okay, if there's my data, the time and data, yeah, and if the system clock is synchronized, okay, it indeed works. So we're going to check the status of, hold on, my light. No, I cannot see it. Okay, so we're going to check the status of Mosquito. So you can see over here, in this window. Let me just try to do this again so you can see it's better. So this one is that currently we can see over here the Mosquito MQTT broker is active and it's running fine. Okay, there's no issues. So we're going to do the test, see what it's going to do. Okay, so we're going to actually use the Mosquito client. Okay. Which is we're going to subscribe to a message. Okay, so we're going to just see the T is the topic. So we're just showing, okay, I'm going to subscribe to a topic called named as a test. Now we're going to simulate it. Okay, we'll just to test it out. Here, I'm going to open another window over here, which you can see. Okay, you can see over here, this is another window. I'm going to use the same thing, but to publish a message, okay? So I still going to publish message under the same topic. Dash T is to, that's for the topic. So what follows it is the topic. So, and then I'm going to send a message, dash M, followed by a message. See, okay, this is first test, okay? And you can see over here is whenever I send a test, and in the window of the subscriber is going to receive the message. Okay, we can try one more. Okay, so this is tested. That means my MQTT broker works fine. And in the later, we're going to use this MQTT for our later projects. One of the things we noticed over here is that I have more details. Sorry, again, running late, but I'll quickly go over this. Okay, so what we see over here, one of the things is we connected is just autonomous. It's like anonymously. Anything who can actually connect it to the node, I'll be able to connect it. There's no password or usernames or any authorizations, right? So we can actually establish that to set up the client authentications. Here's the steps. So with you're going to just create it. There's some of the steps that can create the username, password for the clients. And then only the clients with with that username and password, with the correct username and password, I'll be able to make the connection to the broker, okay, to the MQTT broker. So over here in this case, it's just showing example. If I use my username is no-name and password is workshop, that is what we set it, then it should be communicated properly. Okay. So here's just showing if I run, then it will showing not authorized. Otherwise, they will be able to send or publish or the subscribe through the broker. Okay, so this is what we're showing just over here is local, but you could certainly we need to use the MQTT remotely, right? Remotely. In that case, we use the -H followed by the IP address of that MQTT broker IP address. So you need to find out the IP address, which again, you could use the IF configure or the host -I to find out, okay, which we already showed you previously. Okay, so that's pretty much for today's presentation. I'm sorry, running out late again. Any questions? Any questions? But the presentation have a more detailed steps, so you can follow it step by step. Any questions? You can send, let me check anything. Send the link. Yes. Yeah. If not, looks like you guys are doing fine, no questions. Please, okay, please complete, there's some references materials, and then there's, I have one survey of this presentation. Once you close it out, we'll have a survey. So again, the video going to send you once it is ready. Okay, thank you very much for listening.